They say we should have known better than to fall so deep down into this rabbit hole we found. And I was thinking.
Hi, this is Nikolai, and you're listening to my dad, Rafal, co-host James Jardine, and featuring Mr. Jim Tiller on the one and only Down the Security Rabbit Hole podcast. Plug in, listen up, and enjoy.
Deep into this pool of regrettable situations. Pitch black, think back to the last time that we were happy.
All right, here we go. Good morning, good afternoon, good evening. Welcome down the Security Rabbit Hole, to a caffeine-fueled edition of the Down to Security Rabbit Hole podcast, because it's a Friday when we're recording this and everybody's got their coffee. These guys, Chick-fil-A now has peppermint coffee, and I'm not saying I'm addicted, but this may be my third cup. I can stop whenever I want to. I just don't want to. Anyway, we've got Dustin. Give him a chance to introduce himself, but the one episode we do on AppSec, James sneaks out of. So as I told Jim before we started recording, we're just going to go feral and see what happens. Whatever. You're not here to police us. We'll do whatever we want. So, all right, let's get into it. Happy Friday morning, Dustin.
Happy Friday morning. We're here. We made it to Friday.
Yes. It's like my Bigfoot socks say, believe in yourself. And I believe that I am here. So therefore I must be. Hey, Dustin, tell us a little bit about yourself.
Yeah, happy to. I was a software engineer for over a decade, and then I got into cyber through the AppSec space, actually pretty quick. So I was an AppSec engineer for about 3 whole months, and they were like, this was at Staples, why don't you just lead the whole thing? So at that point, I'm like, welcome to cyber. Now you're leading AppSec, basically, was the way that it went for me. And then rolled out an AppSec program there at Staples, rolled out an AppSec program at Fivetran. Now I do a lot of random things. So I do a lot of thought leadership, sort of speaking and podcast appearances and that sort of stuff as an advocate for Security Journey. I co-founded a company, Catalyst, that focuses on security champions and sort of the cultural elements of the whole thing. And then I do a lot of virtual gigs, right? Or fractional gigs, AppSec, CISO, and so forth. So yeah, lots of randomness, but lots of fun as well.
I want that. I want to do that. Now, you know what? I do enough. I'm a parent. I do enough randomness as it is. Stability. I like stability at this point. It must be an age thing, Jim. We get old enough. We're like, yeah, that randomness stuff sounds fun.
Yeah, I'm okay. I'll just do this.
Yeah, I'm okay. I like getting up at the same time every day. I don't, but anyway, so all right. So listen, we had a kind of pre-conversation about this because we've been chasing getting you on the show for it's been a minute, and I think we finally decided at Black Hat that all right, we're going to do it for sure this year, finally. So here you are, you're real, like Sasquatch.
So. Yes,
this
could be a dream, though. You are real, right? This could all be a dream.
Is.
The only thing we know is that we exist, I think.
This is we are in a good simulation in the Matrix, which makes sense because all that flawed all that flawed code. Listen, I've been chasing. It's funny. I've been chasing software security bugs. It was one of my early things I did when I joined GE. I did a little bit of engineering on the network side. And nobody, this is one of those things where be careful when everybody says, hey, who wants to do this? Step forward, and everybody steps back. You're like, hey, wait a minute. I think I've seen this in a movie once, but I decided, I said, what the hell? I'll take AppSec on. Sounds fun. How hard can this be? Right? Go find bugs and then tell developers to go fix them. I did that. I was actually semi good at it. And that was back in the 2000 to 2005 time frame, when I swear it's really funny. At the time I recall telling my boss, oh my gosh, we don't actually have a full AppSec program. We've got to be the last company in the world. Turns out I was wrong. You were the first by a lot. But it was always the same thing, right? Bugs would show up in code. Applications would get handed to us on a Friday afternoon, and we were told, "Hey, this is going live overnight, Sunday into Monday. Just give it a look. Just go ahead and give us the seal of approval so we can get our firewall ports open and go." And one, that ruined my golf game that Friday, but two, which it's never recovered from, I should say, and two, it was always like, "Oh my God, you can't let this go live. There are more bugs in this thing than like a termite house. Like, what is happening?" They're like, "Well, but we can fix it next time because we don't have dollars to go fix code." Has anything gotten better, Dustin? Like anything?
Very, very little has gotten better. Like, this has been my experience too. I think it's just a general struggle where, there are competing priorities here. It's like, we want to get things out the door. We have to deliver for the business. There's a lot of pressure coming from leadership and so forth to get the release out, which, let me just first say, it's important, right? Like, if you don't have a business and you're not making money and getting the revenue that you need and all that, the whole security thing doesn't matter, right? So
fair enough.
It is a priority, and it should be a priority. But there are also real business impacts to not doing this well, right? Compliance standpoint, right? The customer expectations and so forth. So I don't think you can allow getting away with constantly kicking the bucket down the line, right? And avoiding fixing these things over the long term. What I have noticed, and a lot of the success that I've had, is by showing the actual impact somehow of ignoring these issues, right? And I think, when you start to bring up maybe even ethical concerns, like, hey, we're telling our auditors that we're meeting SLAs. We're not, right? We're telling our customers that we're meeting SLAs, whatever that is. We're not. And to sort of start that conversation, get that in front of more people. Here's why it's important that we have to fix these things, would hopefully align leadership with actually allocating effort to this type of thing. So that's probably a start, but goodness, this is a major nuanced space, with
I was
a lot
gonna
of
say
different
that
issues.
That whole thing of like telling the public we're doing one thing and internally going, "Guys, we are so far behind." It starts to sound like the SolarWinds story.
Yeah,
it's more common than I want to admit. Like, it's just kind of scary. And I'm not going to speak for my own personal experiences for the companies that I worked for, but I will say that I have observed in general that people are not where they should be. And yet they pass audits, right? They get compliance certs and so forth. So how does this happen? And this is one of the mysteries we got to solve here.
But that's not unique to AppSec, and not by. We've had these conversations in security since the beginning of time, is trying to justify to the business, and it's extremely difficult. And AppSec is extraordinarily complex. It's pretty much its own thing off to one side, but proving it and trying to lay it out, whether it be technically or showing some sort of Rosie, remember those old days, right, Raph? Rosie, return on security investments. Remember that silliness? That's the major uphill battle. But I did have a question for you really quick. I know we're just getting started here, but I'm curious to your theories on things like, one is when the code is just too bloated to fix, and people just keep kicking it down the field. How do you handle those situations? And how do you handle situations that are the opposite of that? For example, I work with organizations that feel that they're not up to speed if they're not updating their app every 60 days, right? It's just this whole flow of just constant updates. So you're jamming vulnerabilities into your application so you can have a different font. You know what I mean? So I'm sorry I hope I didn't derail us, Raph, but I'm very curious about this because that's the things that I see that I tend to struggle with, that leadership in that space.
Yeah, there's a lot to talk about here. I think, just to your first question about when do you sort of decide that it's too bloated to fix, I think, unfortunately, you have to make hard decisions sometimes when it comes to that, like scrap the whole thing, and sort of start over. I've been through several iterations of that where, you haven't kept up with the framework updates and the patches and so forth. And now, you're working with essentially a legacy application that you want to hire more resources for, but they don't want to support these old languages and frameworks and so forth. So the best thing to do sometimes is just scrap the whole thing and rewrite it. And that's unfortunate because I think if you keep up on it, if you would have kept up on it and done smaller incremental, changes and maintenance, you wouldn't be in a situation like that. You'd be in a much better situation because think about all the resources that it takes to scrap and restart, right? Not ideal.
Man, that brings me to a really funny story. Many years, and this is mildly AppSec related, but many years ago, there was we had an app back when I was looking for NT4 servers to decommission, it's been a minute. I'm sure there's still some out there, but it's been a minute for me. We kept finding this one system and we couldn't identify what it was, and it turned out it was an NT4 box, but it was running a program that had one major. That all it did was it took the ID card that shop floor workers had, and you'd kind of touch it on it. That wasn't RFID. It was some other it was a barcode. You can run it through, and it would do time cards like automated, right? Rather, it would just sign you in, sign you out, sign you in, sign you out, right, for breaks and all that. And I remember saying, like, guys, this is antiquated system. We need to get rid of this. And we need a cost analysis. I was like, oh, okay, but you need to get rid of this. And they said, no, can't do. They came back a couple of weeks later and said, no, can't do it. So what do you mean you can't do it? I'm like, it's just update it. Like, update the machine. IT will give you a modern server OS. Like, well, here's the thing. This time card app doesn't run on a server OS. And it doesn't run on anything past NT4. I was like, well, just update it. They're like, yeah, we did it. We asked the vendor how much it would cost. They told us $500K. So we're just going to keep this. And I was like,
yep. Okay.
It's so old, right? That there's no step up. It's now a jump, right? That God, I did an episode on this. I want to say into the 100s. It's been a long time. I had Jason Whitty. He was at the U.S. Bank, I think, at the time. They were sitting in his office talking about like ultra legacy things that are so legacy that there's no patching anymore. And we joked that something in payroll ran on Lotus 123 or something like that. And you're like, that does not compute. Like, it doesn't make sense. Why wouldn't they just update it? Because over time we said, oh, we're going to skip this version. Oh, we're going to skip this version. Well, we don't have money. We're going to skip this version. And you get to a point where like, well, how do we upgrade? You can't. Mm-hmm. It's a new thing. Oh, by the way, the database schema changed. The UI is different. System requirements are completely new. So it's basically a new thing. They're like, oh, bad.
Exactly. Yeah, and it's unfortunate when that happens. I do think for legacy systems, just to kind of get back to Jim's question too, especially if you don't have the ability to bring the system up to date, you put other controls in place, right? You put a WAF in front of it. If it's a legacy application, you make sure you have proper logging, monitoring, right? So you can figure out, is anything bad going to happen with this system without worrying about even putting in, the right secure coding. Like I've seen this secure coding practices, right? Like I've seen this where, hey, we want to implement secure coding practices. Here's where it makes sense for newer applications, right? To sort of roll out best practices and so forth. What about legacy? Well, we don't even have, developers who know the language that application is written in. And it's been working fine, I guess, for years. So just slap a WAF in front of it or something. Like, put things around it. Don't worry about fixing the internals. Put other controls around it, surround it with a fence or whatever you want to use for your mental model there. But I think that's just what you have to do. And then at some point you scrap it, right? And you rebuild it if it's that important to the business.
I know I don't want to stay too wrapped around this axle, but I think all of us know of some pretty serious systems and some pretty serious companies that are being held together by a bunch of people sitting in a room with defibrillators, and you know what I mean, and just keeping these things alive. And they do exactly what you're saying, Dustin, because that's the only option. Because we're talking millions and millions and millions of dollars, and not only that, but in some cases, these things aren't really replicable because the system reaches so far and wide because of the way various industries interact with that particular system. I think of, I don't know, without calling out names, logistics and shipping and transportation.
All those things.
Yeah. Finance, that kind of thing. So anyway, I digress, but it is terrifying to think that, things that are so core are sometimes just not fixable and they're not isolatable. It's kind of terrifying.
Yeah, it's a time bomb. And this is where tech debt comes in, as a term that we should probably talk about more, because you're paying interest on that debt as it grows, and I think that's the best way to think about it. And then eventually, you might go bankrupt, meaning you just have to scrap the whole thing and start over. I do want to get back to one thing that we mentioned before, and then maybe we can move on to a different topic. But, in terms of proving or at least explaining why you should be taking secure coding practices seriously, I think never waste a good incident, right? Like there are what I would consider lagging indicators, right? What's in production right now and what are the flaws that are there today? If you do a pen test, for an audit or whatever it is, you're going to have a list of issues. If an incident happens, don't just sweep those under the rug. Like, I think it's really important to come back to it and say, how much time did this cost us? Why did this happen? What's the root cause analysis? And then, show that dollar value and time cost to leadership and say, this is what it cost us. We could have solved this, a year ago when we made a certain decision at this much cheaper price. Or just doing a threat model or doing some sort of review up front of what we built here would have saved us X amount of dollars total. I think that's a really good way to make a strong business case for this.
The other thing that I think of when we start talking about this, every time we start going down this path with legacy systems and vulnerabilities and apps that just live far outlive their duty cycle, right? I start thinking about the way, the way that we did apps back when. I suspect it's probably not too different everywhere. There's companies that do it really well, but I still feel like by and large you get this sense of somebody at some point. This is like at some point you say, okay, we start our AppSec program today. But you didn't start building applications that day. You've been building them for 10 years, 15 years. You start that day and you're like, okay, everything going forward will be reviewed. And like the first couple of years, I always thought when I was doing this and I was young and naive, that it would be like the first couple of iterations. And it turned into like the first couple of months. Then it was like the first several quarters. Then like 3 years in, I'm like, oh my God, this is never going away. But what would end up happening is, what ends up happening with these things is like that we start accumulating like, okay, well, we just this app, we just added this little applet in the corner here. Okay. You're like, okay, like, well, just test that. It's like, that's not how it works, man. This thing is interconnected. It's not like you're going to say, okay, bad guys, don't focus on the other stuff. Like this little thing in the corner here, that's secure. Leave everything else alone. And then you'd find stuff and then they would fix it, or maybe choose not to either fix or wait, and then some time would go by and you go look at it again. You're like, guys, this stuff's here, plus there's some new stuff, and the list never really got shorter. At very best, it stayed about the same because you'd introduce new stuff, then you'd fix some old stuff, but that made up for all the new stuff that you introduced. Like there's a Far Side cartoon, or somebody wrote, maybe it was an XKCD cartoon that was like, for number of bugs you fixed, number of bugs you've added. But it's like the title of this podcast. Like, I feel like in this, particularly in this space in security, it's whack-a-mole. Like something pops up, you try to get it before it comes up someplace else, and you're kind of doing one of these things and trying to see how fast you can react. And in the end, nobody wins those games.
Yeah, I think this is where I would start talking about inventory because I think it's really important to make sure that you're focused on the highest priority systems across your environment. And you can determine that with various variables, right? Like, is this a business critical system? How much is it a dependency for other systems? Is it public facing? What are, what's the data that it handles, right? What's the essentially sensitivity of that data? So instead of it being a whack-a-mole, this just popped up and sort of reactive thing, it's moving you toward more of a methodical approach. We really want to focus on, and like you said, a single system to start, which is a good thing, right? Even if it's not, completely covering all of the risks across your environment, at least you're starting with something. And if you can demonstrate that you're starting with more of the higher risk systems, then I think that's a good thing, because you can show that progress, right, over time. But you got to start somewhere, right? And I think this is where AI can help as well, right? Really understanding the environment. AI. You knew that I would bring up AI during this call.
I do.
Of course.
I mean,
we have to talk about that at some point. But just helping to prioritize, right? And even just understand your environment. I think there's a lot of potential there, for AI to play a role.
Hey, help me understand, because I think I have a decent grasp of how AI training works. How do you train AI on app vulnerabilities? Like, I'm just logistically, how do you feed it output? Do you feed it code? Like, how does a training model for AI work when it comes to AppSec?
Yeah, I think the core issue right now with the AI models that we have is that it was trained on all code written everywhere, right across the internet, which the variability of whether it's secure or not is just completely up in the air. So if you don't ask for it, and I think this comes down to prompt engineering and techniques that you can use to get the result that you want out of your AI assistant, to ask for it, because in all cases that at least that I've seen, you can say, hey, write me at least initial prototype or code for this. It writes something and you're like, geez, there's security flaws everywhere here. This is ridiculous. We're not sanitizing input. We're not doing the things that we need to do. And then if you just ask the assistant, hey, rewrite it securely, it does a decent job. So it's like it knows what secure looks like. It's just that you didn't necessarily ask for it. Right. So,
wow.
And I think this is important, because you can configure your AI assistants as well to write secure code by default. Right. I don't know how much you've gotten into this, but you could essentially set up profiles, or if you think about, or even, GPTs in the case of ChatGPT, that are customized, that you could sort of preload rules into, so that whenever you do ask for code, it knows to produce secure code down to specific rules. So when I think about things like OWASP, ASVS, the Application Security Verification Standard, which is really this comprehensive list of the things that you should do to build a secure app, can you preload a lot of those things, especially in the context of your environment, into the assistant so that it produces secure code according to those standards? That's the way that I like to think about using these assistants to write secure code.
How do you so there's AI writing, code, and then there's AI finding bugs in code, right? Those, I feel like those are two different things. How do you get AI to find the bugs in the code? Like, is that helpful?
I think it's helpful, yeah, because of what I was just sharing around the fact that for the most part, these models can identify things that are secure or not, especially according to the rules that you set, which is the prompt engineering piece that I was just mentioning.
Well,
so AI as judge. Sorry, just one quick point. Like, using AI as judge is sort of one way to think about it. Like, maybe have one AI produce code that you're refining and so forth. Use a different session or thread or whatever you want to say, or even a completely different assistant to then review that code and review it in a way that is, producing where it's insecure. So sort of using AI to check AI's work is the concept.
So Dustin, you just, I don't know if anybody's ever said it out loud before, but I think you just recommended a GAN model for application development, which I think is pretty freaking cool, by the way. So, hey, you heard it first here, I think. I'll have to do some research on that. That's actually really, really cool. I think but when I interrupted you, apologies, the $64,000 question I want to ask you really quick is just basically, well, you're talking about like building models in now a GAN app dev environment, which I think is cool. Would you fundamentally agree or disagree with the statement that vibe coding, or whatever we're calling it now, AI generated applications are going to become over time introduce more security issues? Is it going to create a higher volume of vulnerable applications and code? And then are people going to start learning from that code and then propagating more bad code kind of thing? What are your thoughts? I mean, what is the role of AI moving forward as it relates to the volume of vulnerabilities?
Yeah, I think there's a lot to unpack here. I am concerned with the whole vibe coding movement in terms of, I'm going to try to say this as polite as possible, but folks who aren't experienced in creating code are now able to create code without bringing in that experience, right? Without even knowing what to look for. Is this high quality code that I just produced in terms of security, whatever it is? It's more like, I'm a product person. I just need a product. Cool. I don't have to hire an engineer. I'm just going to produce something without all of the, quality best practices and so forth that an experienced software engineer would know how to produce, right? So I think that naturally is going to create an influx. And I think we've already seen an influx of insecure code out there in the world. And then will that feed back to the models to produce potentially more?
That's what scares me.
Yeah, very likely for at least a while. But I also think, like you see with Aardvark, I don't know if you've looked into Aardvark at this point, but it's basically a secure code checker that was produced by OpenAI. And so they're already starting to think about, how do we ensure that the code that's produced by our models is secure? We want to verify it, but I also think at some point they're going to go to the root of the actual model initial generation of code and put rules in that is going to produce more secure code. They have that data. Like I said before, the models, they already know what secure code looks like. It's just a matter of asking for it. So why not just hit it right at the root and have the AI assistant developers do that for us? And I think that's just a matter of time. I give us 2 years max before we start. Yeah, before we start seeing the model creators, model developers producing secure code by default. And then I think that's really going to hit at the heart of the issue.
So this goes back to the vibe code bros out there and on LinkedIn that 6 months ago predicted that we wouldn't need developers anymore. I was just going to write all your code for you. It'd be great. Fire your developers now and get ahead of the curve. It turns out it didn't work that way. Are we ever going to get there? Or are you still going to need, because the suggestion was there's like developers or bust. Never mind, AI is going to eat all those. All right. So the opposing, and I think it's settled somewhere in between in that particular fight. I think it's settled somewhere in between, which was, we're going to get a person that's going to start kind of like, here's what I want. AI will generate some code. The person's going to look at it and go, yeah, that's good. That I don't like that. Let's do it a different way. That's good enough. Okay, refine that. It'll be iterative. So machine assisted, as opposed to like fully, write a spec and AI is going to crank out code for you.
Yeah, I like to think of this in terms of levels of abstraction. Like when we think about when code first came about, what did that look like, right? Ones and zeros, machine language, and so forth, punch cards, right? And then you went up to assembly, and then you went up to third generation languages, right? That abstracted away a lot of the assembly details. that's like C++, Java. Those are all in that that third tier. I think what we see with AI is another level of abstraction on top of that. Now, that doesn't remove all along the way. It doesn't remove the need for folks that have the expertise to create the compilers, right, that are going to translate C into assembly. Okay, so you do still need today even developers who are able to do that kind of work. And I think as we go from third generation language or even fourth to more AI generated code, you're going to need maybe less of those folks who are able to do that translation and create and make sure that secure code is being produced and so forth. But I think for the most part, it's abstracted. You're actually finding more and having more people who are maybe product people, right? Thinking about what do I want to produce, who are, thinking about what, not how, is kind of the way that I think about it. And then the AI assistants will help sort of generate the third generation language code that's going to make that a reality. Ooh. So we will still need developers, but I do predict that we're going to need less of them, and that we should try to think higher order. If you want to maintain your, I guess what I would say, value in the market, it's really right brain thinking, right? Entrepreneurship, trying to come up with these new concepts for apps and so forth. I think that's probably where a lot of people are going to land.
See,
but again,
that
doesn't remove the need for developers who know what they're doing as well.
But I you talk about, like, I learned in school, and basically that's where my coding experience comes from back in college. It was assembler, then it was C, and then, like, as we went into C++, I was like, oop, doesn't make sense to me. I don't understand this. And we got into Java, I was like, no, can't do it. And it's got, as it got more complex, my brain was like, you're not going to be a developer, just give up now. And so, but I can still go back and read C programs all day long, right? Which is crazy. But what troubles me is I'm thinking of this kind of and again, I'm not an AppSec guy, I haven't been for a long time, but I'm thinking of this in the reverse. As we continue to build abstraction layer on top of abstraction layer on top of abstraction layer, and we're abstracting things away, somebody still needs to know how this stuff underneath it works, right? Exactly. So it's like my kids, they just expect that, like, they can pinch zoom something and it just works. Like, and when they were small, they walk up to the TV and try to, like, move things. I'm like, no, that's not a touch medium. Like, well, why not? Like, how else does it work? Well, there's this thing called a remote. Like, back in my day, it was part of the TV. Anyway, but, like, some people have to know the mechanics of how packets move, how registers, how moving registers and bits and bytes, and back in the days when you could create a really cool demo file out of, like, 8K of a burning flame and, like, a cool logo and all that stuff, right? As we continue to abstract, I feel like code size is growing, which means we need more powerful computers to run it. And maybe the phrase is wrong, but I don't feel like we're thinking about optimizing it for like, make it run small. But it's like, oh, we got all this compute available, you might as well use it. No, that's the wrong way. And then security vulnerabilities come with that, because it gets more complex. And we're back to whack-a-mole. Like, hey, as a pen tester, there's no chance that you're going to go through every code pathway in the application if it's any reasonable size. Like, there's no chance, right? Maybe AI can do it.
Well, I think, if I may just jump in real quick, as I think the one difference between somebody's got to know that, I completely believe in what you're saying, Raph, with regards to layers of abstraction. It's gotten totally ridiculous, right? And the more layers, the more gaps there are for bad guys to sleep in. I think we're all in agreement. And absolutely, people go, wow, I've got more power and quantum on the way. I don't care how fat my code is. But I think, and I might be getting a little bit theoretical here, I'm very theoretical, is AI as a type of technology we actually haven't had that exposure to. Like, what's to say that AI doesn't come up with a completely own set of code? This whole, like, concept, and frankly, Dustin, you kind of said this. I didn't. You slipped it in there really quick in what you're taught earlier, maybe on purpose or not, or maybe I'm just hearing things. Is probably likely, but I think it's going to come a certain point where it's almost like, low code, no code kind of stuff. Like, I just want to have this box here, and then something happens in the background. And there was a time, I believe it still is, that somebody really needs to know, right? But I mean, more often than not, I talk to IT professionals all over the place, security professionals that don't really know IP routing, for example, right? I'm like, okay, well, do you really need to know it? Maybe only if you need to work in, yes, you do. Okay, but that's not the point. But if you worked in a giant, yes, I do. I'm just saying that's not today's reality. And I'm wondering if if AI is going to get to the point where it just kind of comes up with its own language, so it can do it faster, more compressed, and it exceeds our ability, but also not necessarily our ability, but our desire to even want to do that. I think when it comes to app dev, we're at a very critical juncture when it comes to AI. And Dustin, I'd be very curious what your thoughts are on that. But Raph, I didn't want to counterpoint your point, but I don't know. I think we're dealing with a different animal. I really do.
Yeah, I mean, think about it like this, and I have experienced this because I like software personally more than hardware. Okay. Do you have to know all the details as far as how a computer works to be an effective software engineer today? And I would argue, no, you don't. Especially if you want to focus on, let's say you're a front end developer. You're really good at all those frameworks, React and HTML and all that stuff. Okay, cool. I just want to make a website that's dynamic, that looks good. That's what I do. That's what I specialize in. Again, do I have to know all the details about how things work on the hardware side? No. Frankly, there are people who concern themselves with that. So I think what we'll find over time is just more specializations like this. And we've already sort of seen this. It's, back in the day, the early computer science folks had to know all the details, but I think it's specialized over time. And you have folks that just focus on different areas and they don't have to know all the details of all of the other areas. And I think it's hard for folks who have been around a while, like me, to hear that and see that. There's like this appreciation that you want people to have for how things are working and how far we've come. But frankly, to the younger generation, it doesn't matter. Can they just stand on your shoulders and take what you've done and build the next generation of it on top of what you've done without necessarily understanding all of it? It makes me think of this just as another analogy. I really want my son to understand and play Mario Brothers. Like, he's big into Minecraft and all that, Roblox and stuff. And I'm like, yeah, but where did this come from? I want you to understand the history of video games. Please play Mario, and he plays Mario and he's like, it's not for me, And I'm like, oh, but it's beautiful, because back in the day it was beautiful, but now he's just like the newer generations. They've sort of moved on more or less. Right. But it couldn't have happened without what we did. But now, is it okay that they just move on and stand on our shoulders?
Okay, so final thoughts. We're up on time. In fact, we're over time, but that's okay. We have this is the kind of culmination of this entire conversation. We have legacy code. We have developers that have now, as you said, specialized. Right? We've got people that know how to move things between registers, and then that don't really care for how all the UI stuff works. And people know how to paint this box green and move it over here, but don't have no idea how that actually happens in on the processor or the video card. And then there's the hardware, the software, and the interface between the two. The thing that troubles me and where I lose real mental cycles I get stuck on this is it's always been the bridges between these things, right? Somebody that's building software for a piece of hardware they don't fully understand, or a piece of hardware that has its own bugs in it that no matter what you do on the software side, you'll never be able to fix it. A processor bug. Mm-hmm. that you just have to like, the fix is you restamp the processor. Like that's the fix. And now, so so that pair has always existed. There's been bugs in there, the ghost has been in the machine and many ghosts for a long time. Now we stack abstraction layers onto it, and people that specialize at the various layers, but nobody really understands because it's so complex and Jim's point, so abstract. Nobody really understands how we get from, maybe it's not nobody, but there are very, very few people that understand how we go from the mouse click you make or the touch on the screen that you make to a transaction that happens that moves money from point A to point B. Or let me be more precise. The app that I have on here and how I interface with this that goes over the internet back to my child's phone that controls their insulin pump. Or the interaction of a CGM to a cell phone over Bluetooth through the internet back to another app over the internet over Bluetooth to an insulin pump on a closed system like that. The amount of abstraction, the amount of protocols, the amount of interface in there scares the shit out of me, pardon my French, because it could kill someone, quite literally, completely by accident. And because very few people understand end to end how that works. And now sure, we're going to develop a nth layer of abstraction on top of everything else. While that sounds really cool, to me, that just screams like we're going to get to a point where nobody actually understands how the background stuff works. And then something breaks and we all just sit and stare at each other like, I don't know. What does that even do? How do you get that?
Yeah. Well, I think someone has to understand. Period. I think it has to do with who is interested and who is potentially in the best position to understand that. And I think it's case by case, right? But I do think someone has to understand it. But they also don't have to understand other things, right? So this is where the specialization comes in. Maybe someone's specialty is to understand how that entire system works, more or less, so that they can offer direction, guidance, advice, etc., to maybe people that understand at a lower level of abstraction how that specific system works, right? That has to talk to another system. But that's all. I mean, we all need each other, I think, is the point. I don't think you can have one person know all of that, know how to do the front end coding and fight with HTML, goodness gracious, but also understand all of the intricate pieces of how everything works all the way down to the hardware layer. It's not possible. It's like when you think of the smartest people like Einstein, who understood a lot of things, but he didn't know everything. He didn't know all the languages in the world or something. So you have people that are skilled in different areas. And I think the whole question here is what's the best way for all of us to bring our collective knowledge together, right? To produce something and be productive.
Yeah, I'm going to say that I think the answer is still in the bridges, in the interfaces. You build the cleanest interface between the thing that you are responsible for and the thing and the interface to that thing, right? We can call them APIs, we can call them whatever.
If that's your interest, though, if you are responsible for building that interface, because again, what if you're a front end designer who knows how to code a little bit and you can do HTML, and you don't care about the interface? What you care about is usability, right? You've got this entirely different focus. What I want to do is figure out the best place to put the widgets on the page to motivate users to take it seriously. There's a whole science behind that. Again, someone doesn't need to know
I get that.
The hardware and everything, right? So
yeah, I get that. All right. I think that's a good place to leave it. I think there's a debate I think we could have and probably should have at some point about specialization and have we over specialized. I think by necessity we've sort of gone, when we collectively started, you did routers, you did switches, you made firewall rules, you did permissions on workstations, and you did everything. Now we're so specialized because it's gotten so deep. No, everybody's an inch wide and a mile deep. And it's the opposite of where we were 25 years ago, right? And some of that is by necessity. But again, maybe I'm just too old to understand, to really be useful here. But I feel like this is everybody's world. And when it comes to like commenting on something over here, they're like, well, that's just dumb. Why wouldn't you understand that? Like, this is how it's supposed to be. And you're like, but like, look at the actual thing. You're not paying it. Like, you're not seeing it. And I don't know. I think that becomes, I'm not opposed to abstraction in these situations. I'm not opposed to any of that, right? I think abstracted languages are nice because they make things easier for people. It just worries me that we get to a point where things are so abstract, we don't actually know how they work anymore. And as AI starts to write code for us, and Jim, God help us if it writes its own language, if AI comes up and writes its own language, because then we actually don't. It's hieroglyphics. It might as well be Swahili, right? Like, we don't actually know what it's doing. So is it secure? I don't know. Trust AI. It says it's secure. That's kind of scary.
I think it's coming.
Yeah, probably.
I think we could debate that more, but I do think some people are tunnel visioned on how it works too. Like, they're not actually producing products, et cetera, that people are using. What they're doing is they're tunnel visioning on how all these systems work.
Yeah.
And I think that's a different specialization that I think we'll continue to have. So I do think some people will know how it works end to end. It might be less.
Yeah. Maybe that's the answer.
Yeah. And I think that's the answer, but I don't think we have any choice, because I think there's just so much to know that it's really our collective knowledge that matters here. That's true. You have a lot of people that are specialized.
Yeah, that's true.
Like, you could consider that inch deep, or what did you say? A mile deep,
mile wide. Yeah. Mile deep.
But you could apply that to someone knowing how the entire system works too. That doesn't mean that they know all the details of all the components of the system, but they do know the bigger picture of how the whole thing works.
That's fair. All right. Well, we'll have you back. We'll do this again. Thanks for being on, man. It's been fun. It just reminds me that AppSec is still messy.
It's all messy.
And everything's
tech is messy.
Yeah. But everything's an app. Think about it, right? I mean, this is the juggernaut, right? This is the juggernaut. Mm-hmm.
If I could, I want to have AI generate me a 10-second clip of somebody playing the kid game of whack-a-mole while REM's End of the World as We Know It plays in the background. I think that's right. I think that's the best way to. I think that's the best way to sum all this up, in my opinion. But maybe it's the dawn of a new age, and it's okay that the old world's ending, or maybe it's really time to go find a bar to attend at a private island somewhere. I don't know. We'll see.
That is an option. We all have to make those personal choices.
Thanks, Dustin. You've been a fun guest. I hope you enjoyed it, folks. Thanks for listening. This has been another episode of the Dama Security Rabbit Hole Podcast. That's Dustin Lair over there, and it was fun having you on, talking AppSec and the whack-a-mole world that it has been and maybe still is. So, you guys, thanks for listening. We'll catch you guys another time, another place on another Down the Security Rabbit Hole podcast. Ciao, y'all. See you later. Bye-bye.
This is Bella. Thanks for listening. Don't forget to leave my dad a review and share this with your friends. Bye.